Hey everyone, so today's lesson is on solutions composition. So we already have one way of kind of identifying the composition or kind of defining how a solution is made up, and that's through molarity. But there are multiple other ways to define a solution's composition. We could do it through mass percent, we could do it through volume percent, and we could do it through mole fraction. These are the most common ones that you'll see. Mass percent is obviously just mass of solute over mass of solute and solvent. So it's taking the mass of what we put in the solution and then taking the mass of that total solution and then timesing it by 1,000. So mass of what we're dissolving over mass of the total solution times 100%. Volume percent is very similar to that. It's just using the volume, right? So we take the volume of the solid that we put in there, or maybe an acid that we put in there. We take the volume of the total solution underneath of it, and we times that by 1,000 as well. So very similar to mass, we're just using volumes instead. And then 3, the last one, is a mole fraction. We take moles of what we dissolved over the total moles of everything. So if we take salt and dissolve it in water, we take the moles of the salt divided by the moles of the salt and the moles of the water. No need to times by 100 here because this is not a percent, this is a mole fraction. So let's go ahead and let's do some quick examples of these, and that way you can go ahead and figure out how to define a solution based on its mass, volume, or its mole fraction. So our first example here, it says I have 90 grams of H2O and 46 grams of NaCl. Find the mole fraction of NaCl. So I'm putting these two chemicals together, making salt water essentially, and I want to find the mole fraction of these. Well, if you look back into your notes after writing down those formulas, mole fraction is just moles of what we're looking for over mole total, right? Well, here it wants the mole fraction of NaCl, so our component is going to be NaCl, and then our bottom is just going to be the moles of both of these added together. So let's just go ahead and let's figure out the moles of both of these right off the bat. Let's go ahead and find 90 grams of H2O. To get grams of moles, we divide by molar mass, which the molar mass of H2O is 18. And that's going to equal 5. Okay, 18 times 5 is 90, right? So 5 moles of H2O. And then the moles of NaCl, we got 46 grams of NaCl. Right, we got to divide by the molar mass of NaCl, which 23 plus 35.5 is 58.5 grams per mole. Let's just put grams per mole there. So let's go ahead and let's take 46 divided by 58.5, and we get something like 0.79 moles of NaCl. So again, we're doing mole fraction, and I want the mole fraction of NaCl. If it wanted the mole fraction of H2O, I'd put 5 moles on top. But since it wants the mole fraction of NaCl, I'm going to put its moles on top, 0.79. And then on bottom, it's just our total amount of moles. So our moles of our salt and the moles of the water. So it'll be 0.79 plus that 5 moles of water that we dissolved it in. So let's go ahead and let's take 0.79 divided by 0.79 plus 5. And we will get a mole fraction of 0.136. No units, no need to times it by 100 because it's not a percent, it's just a fraction, okay, a decimal. So that's it for mole fraction. Let's go ahead and let's do another example. So our next example here states, what is the mass percentage of magnesium in a solution with 2 moles of magnesium, 4 moles of potassium, and 3 moles of H2O? So here we're not dealing with mole fraction anymore, we're dealing with mass percentage. And I gave you everything in moles. Well, moles aren't going to help me, right? Because we're dealing with mass, which is grams, okay? So let's just go ahead and let's change all these moles to grams by multiplying by the molar mass. We got 2 moles of Mg, right? And we got to get it to grams, so we're going to multiply by the molar mass of Mg, which is 24.3 grams per mole. Okay, so that gives us a total mass of 48.6 grams of Mg. We got 4 moles of potassium. We're going to do the same thing. We're going to multiply by the molar mass of potassium, which is 39.1 grams per mole. That gives me a mass of 156.4 grams of potassium. And then the last one, right, we got 3 moles of H2O, which if we times by 18 That'll give us 3654, I believe. Good. My math is still on point. Okay, so now we've just gone ahead and done the first step of making sure that our units are all correct, that since we're getting a mass percentage, we got all these in grams. And what it wants is it wants the mass percentage of magnesium. So that is the mass that we're going to put on top. So if you remember, our mass percent is mass of solute, so in this case magnesium, over the mass total. So we got 48.6 for the mass of what we're looking for, the mass of our solute. And then on bottom, it's just going to be all the masses of the total solution, which in this case is the mass of the magnesium, the mass of the potassium, and the mass of, well, water. Okay, this solution is probably super saturated solution, okay, because I just can't imagine dissolving all that solid in just 54 grams of water. And then, of course, since it's a percentage, you can't forget to times it by 100. So let's take 48.6 divided by 48.6 plus 156.4 plus 54 in parentheses. That gives me a decimal of 0.187. But if I times that by 100, it gives me a percentage of 18.76%. So it is 18.76% magnesium by mass. If we wanted to figure out the percent for potassium, we put potassium's mass on top. If we wanted to figure out the mass percentage of water, we put water's mass on top. Okay, simple as that. Let's go ahead and let's do one more of the final example, which is volume percentage. So our last example here, you're just mixing 50 milliliters of HBr with 110 milliliters of water. What is the volume percent of HBr and water in solution? So I just want the volume percent for both of these guys. So you're going to have two percentages at the end. So remember, it's just volume of what we're looking for on top over volume total. Okay, they could be in liters, they could be in milliliters, it doesn't matter as long as they're all the same unit. So let's do HBr first, right? HBr's volume is 50 milliliters. And then we put that over the total volume, which in this case is 50 plus 110, which is 160 times 100%. And that'll give us the percentage of volume of HBr. So 50 divided by 160 is 0.3125 times 100 is 31.25% HBr, of course, by volume. And then we got to figure out the volume percent of water. Well, water makes up 110 milliliters of the 160. Or if you really wanted to, you could just take that percentage minus 100, right? But I'll go ahead and do it the long way. 110 divided by 160, mass of, or volume of water over volume of total, gives me 0.6875 times 100, which gives me 68.75% volume of water. Okay, those are our three types of solution composition equations that you'll see. Nothing too crazy, just make sure everything's in the right units and that you're putting the volume or mass or moles of what you're looking for on top over the moles, mass, or volume total. That's our lesson. Try out the practice. Let me know if you have any questions. Have yourselves a great day.